1, 2, 4, 7, 11. What number comes next? Try to guess it head on and you get stuck fast. Look at the jumps between the numbers. 1, then 2, then 3, then 4. They keep changing, so there is no single amount you can just keep adding on. So the list just sits there looking like a riddle. It feels random and a little unfair, but it isn't really hiding anything from you. The rule is sitting one floor down in the spaces between the numbers. The rule is in the gaps. That is the whole idea today. Stop staring at the numbers themselves. Subtract each one from the number right after it, and the pattern you could not see walks straight out of the differences. It sounds too simple to be a real method, but watch how far it carries you. Start with an easy list so the method is clear. 1, 4, 7, 10, 13. Under each pair, write the gap. 4 minus 1 is 3. 7 minus 4 is 3. 10 minus 7 is 3. Every single gap is 3, right down the row. That steady 3 is the entire rule. The sequence just adds 3 at every step. So the next gap is 3, and 13 plus 3 is 16. Then 16 plus 3 is 19. A flat gap row always means a steady, even climb. Now back to the list that stumped us. 1, 2, 4, 7, 11. Do the very same thing and subtract each pair. 1, 2, 3, 4. This time the gaps are not equal, but look closely at what they are. They are simply the counting numbers. That is the rule we could not see. The gaps count up by 1 each time, so the next gap is 5, and 11 plus 5 is 16. The gap after that is 6, so 16 plus 6 is 22. The random list was hiding a plain, steady count. Let us make it meaner. 1, 3, 7, 15, 31. Head on, those jumps look wild and hopeless. So take the gaps instead. 2, 4, 8, 16. They are not counting up by 1 now. Each gap is double the one before it. The gap row still gave up its secret, just a different rule this time. The next gap is 32, so 31 plus 32 is 63. Then the gap doubles to 64, and 63 plus 64 is 127. Wild-looking jumps, cracked by the same one move. Here are the square numbers. 1, 4, 9, 16, 25. They feel like they belong to multiplication, not to gaps at all. Subtract neighbors anyway. 3, 5, 7, 9. The gaps come out as the odd numbers, in perfect order. So the pattern was hiding in the spaces the whole time. The next gap is 11, and 25 plus 11 is 36, which is 6 times 6. Even a list built from squares folds right open once you read its gap row. Sometimes the gap row is still a mess, and you feel stuck again. Take 2, 5, 10, 17, 26. Subtract, and the gaps are 3, 5, 7, 9. That is not flat, so do not quit there. Just do the same move again and subtract the gaps. The gaps of the gaps are 2, 2, 2. Now it is flat, so the rule was underneath after all. The next gap grows by 2 to 11, and 26 plus 11 is 37. When one row will not settle, difference it one more time. Subtraction is powerful, but it is not the only tool you have. Take 1, 2, 4, 8, 16. Subtract the neighbors and the gaps are 1, 2, 4, 8. That is the same list you started with. Differencing got you nowhere at all. So change the question. Instead of subtracting, divide each term by the one before it. 2 over 1 is 2, 4 over 2 is 2. Every ratio is 2, so each term simply doubles, and the next one is 32. When gaps fail you, check the ratios. That doubling looks gentle, but it runs away from you fast. Picture 10 empty boxes. Put 2 candies in the first, 4 in the second, 8 in the third, doubling for every box. Now guess whether 100 candies can fill all 10. They cannot come anywhere close. The 10th box alone needs 1024. Add every box, 2 plus 4 on up, and the total is 2046. Doubling starts tiny and then blows far past 100 without warning. That is the ratio rule biting hard. Once a gap is steady, You do not have to list every term to reach a far one. Take 1, 4, 7, 10, adding 3 each time. The first term is 1, and every step after that adds one more 3 onto it. So term number n is 1 plus 3 times n minus 1, which tidies up to 3n minus 2. Want the 100th term? 300 minus 2, so 298. You jumped straight there without writing 99 numbers first. It runs in reverse as well, in 2, 5, 8 and onward, which term is 101. Each term here is 3n minus 1. Set that equal to 101, and n comes out to 34. So 101 is the 34th term. Now a real warning. You see 2, 4, 8, and your brain shouts, double it, so the next one is 16. Slow down and keep reading. The actual list is 2, 4, 8, 14, 22. Subtract the neighbors before you commit. The gaps are 2, 4, 6, 8, the even numbers. It was never doubling at all. Just 3 terms were enough to fool the eye completely. The gap row is what told the truth, so difference first, and only then trust a guess. Step back and look at what stayed the same across all of them. Every single time, the move was identical. Subtract the neighbors, then read whatever falls out of the gaps. That one habit turned a pile of riddles into rules you already knew. And it stacks up into a ladder. Flat gaps mean a steady add. Patterned gaps mean subtract again, or switch over to ratios. You keep differencing until some row finally goes quiet, and then you climb back up to fill in the answer. Your turn now. Here is the most famous list of all. 1, 1, 2, 3, 5, 8, 13. Take the gaps yourself before I do. Something strange happens. The gaps come out as the very same sequence all over again. That is because each term here is the 2 before it added together. So 8 plus 13 is 21, and 13 plus 21 is 34. Even this famous list gives up its rule the moment you stop and read the gaps. Try another one. 1, 3, 6, 10, 15. Pause the video and take the gaps on your own before I say them out loud. They come out as 1, 2, 3, 4, 5, the counting numbers all over again. So the next gap is 6, and 15 plus 6 is 21. These are the triangular numbers, the running totals of 1, then 1 plus 2, then 1 plus 2 plus 3. The gap row shows you exactly why they grow the way they do. Last one, and stay on your toes. 3, 6, 12, 24. Subtract the neighbors and the gaps are 3, 6, 12, still growing fast. That row did not simplify, so reach for the other tool and divide instead. The gap row grew instead of shrinking, which is your clear signal. 6 over 3 is 2, 12 over 6 is 2. The ratio holds steady at 2, so the list doubles and the next term is 48. Notice how you picked subtraction or ratios based only on what each row was telling you. This is a lot more than a puzzle trick. Steady gaps are how regular savings pile up and how rows of seats add on. Square numbers count areas directly. Doubling drives cell division, where 10 splits turn a single cell into over 1,000. And long before calculators, people built their first math tables by working with these differences instead of the raw numbers. Reading the gaps is a genuine method that runs all through mathematics. It is not a one-off party trick. Astronomers and engineers leaned on it for centuries. So when a row of numbers will not talk to you, stop staring straight at it. Subtract the neighbors and read the gaps. Almost always they turn into something you already recognize, a plain count, a doubling, or a flat step, and they hand you the rule. That's all for this video.